Hello and welcome to my channel. In today's lesson, we will consider the notion of a field in abstract algebra. We will start our lesson with a motivation. Let's consider that we want to work with certain objects in space, and these objects are arrows. Now, if we consider an arrow in this direction, we also want to look at arrows in reverse direction. So if we reverse the direction of this arrow, we get this other arrow. Now we want a convention for the directions of these arrows. So if we have an arrow moving in the forward direction and same arrow, we've moved it to the opposite direction, we use the convention that the forward direction is positive direction and the backwards direction is the negative direction. Also, these objects, we want to be able to scale them in the sense that if we have an arrow, we want to find fractions of this arrow. So if we have this arrow, we could consider half of this arrow. So half of your arrow. So if I call my arrow, let's say A, then we have half of it, but we could also consider scaling it above beyond itself. So we could also consider twice of your arrow. So that means we want some objects which have some scalars, which we can find fractions in. But we also want to be able to add these arrows. So if we have this arrow and we have another arrow, we add them by what? Continuing with it. So if we have an arrow of this form, which was your half A, we can add this other arrow to it by continuing with it from where this one ended. So plus 2A. So we want to be able to add these two to get a certain number. So the numbers that we are considering, we should be able to add these numbers and we want to get some other number that will give us another object. Now, so these numbers that we have here should have certain properties, and these are the properties that we need in order to get these arrows to be able to be added and scaled. These properties are what we call the properties of a field. Okay, so for a field, we want to be able to find scalar fractions of the scalars. Okay, so fractions of the scalars, because in our arrows, we want to be able to either scale up or down. They should also have negative numbers because we want to look at reverse directions of our arrows, but we should be able to add them. So this is why we get all the axioms we get for a field. We want scalars that you can divide, you can add, you can subtract. But finally, too, we want that if we consider this arrow moving in the forward direction, same arrow moving in the backward direction. So if you want to add these two arrows, so if we go forward direction, which gives us A, and we want to add it to the backwards direction. So forward direction ended here, and the backwards direction, if you want to add it to the backwards direction here, minus A, it means that we started from here and ended here, which means we did nothing. So you want a notion of nothing, which we will use a convention as what? 0. So in this scalars, so you want something that has to do with what? Nothing. So these properties all come together to give you what we call a field.